Hello. I'm going to be doing a mean test matched pair. So, here's the question. A crossover trial investigated whether eating oat bran lowered serum cholesterol levels. 14 individuals were randomly assigned a diet that included either oat bran or cornflakes. After 2 weeks on the initial diet, serum cholesterol were measured, and the participants were then crossed over to the alternate diet. After 2 weeks on the second diet, cholesterol levels were once again recorded. So we are given cornflakes right here and oat bran right here. So because this is a matched pair, the first thing we do is that we take list 1, which is cornflake, and list 2, oat bran, and we subtract each value in the sample. So we do 4.61 minus 3.84 to get 0.77, 6.42 minus 5.57 to get 0.85, and so on until you get all the way down here. So then after that, you can start doing your steps. So first, do parameter. So in this equation, we find that the parameter is the true mean of differences. Notice how it says the true mean of differences. This shows that this is going to be a matched pair because we are finding the mean, we are finding the difference, we're finding the true mean of the difference. So we're finding the mean of the difference of this sample. So the true mean of differences of serum cholesterol levels when eating cornflakes versus when eating oat bran cereals. Next, we find the hypotheses. So first we find the null hypothesis, which would be MO equals to 0. Because there is no difference, there is no claim that is being made, so we just put 0. The alternative hypothesis would be MO equal, it would, for this equation, we will have to put, it is greater than 0 because we are trying to find if oat bran lowered serum cholesterol levels. So we're trying to find if so yeah, this would be greater than 0. Next, we find the conditions. So first we find that the sample has been randomly assigned, so the sample is random. We find the 10% condition by finding the population size and see if it's 10% greater than that. So there are 14 samples, 14 data values. So it would be n is greater than or equal to 140. So there are more than 140 or more than 140 cereal boxes. Lastly, we see that we find the normality condition. So with this, 14 is less than 30. So with that, we create a box plot by going into our calculator and plugging in the values. We do that by putting second, y, or no. You go to stat, edit, and then you plug it in, plug in the values in here, and then you go to second y, plot, and then you graph, and then you get your graph. Or your box plot. We see that there is a slight skew but no outliers, so we meet the normality condition, so that's good. Next we go for the description of the sampling distribution. We find that this would be a t because we're using means. We find the degree of freedom, which is n minus 1. That would be 13 because there's 14 samples, 14 data values, and so we don't know what m is, so we put 0. And then we put in the standard deviation of the sample. We find that in our calculator by going to stat, calc, 1 var stats, list 1, and then calculate. And then we put in the sample number in the denominator. And then next we go to work, and then we make our sampling distribution. 0 is in the middle because that's what we're trying to see or find out. And then we find the mean of the sample on the calculator by doing what I just said, and that will give us 0.036. So we put that on our graph because that's what we're trying to see that's what we're trying to find in our equation. So to find that, we find the t-score. So we put the mean, which is 0.36, minus 0 over the standard deviation of the sample over the radical of 14. This would give us 3.28. And then to find the p-value for this, we find TCDF on the calculator. We go to second vars, go to TCDF, and because we are finding, we are going greater than, we are finding what is greater than the mean, we go with 3.28 as our first because that's what we found in our t-score. We put that into our calculator. Then we go 1000 because we're trying to find all the values up here. And then we put in the degree of freedom, which is 13. And then we get, here I'll write that down. This would give us 0.003. And lastly, for our conclusion, we write that with a p-value of 0.003, which is less than the significance level of 0.05. We reject the Ho. You reject the Ho in favor of Ha. There is strong evidence for the Ha that is significant lowering of cholesterol serum. Levels with oat bran cereal.